Okay, so now I'm going to be discussing Chapter 4, Network Basics. Network Basics, now you know that we're creating web pages. So we have to know a little bit about networking to, just to have a good idea of what's going on. So for IP addresses, I know a lot of you have probably already heard of IP addresses. And basically IP addresses are the addresses that allow you to receive and send data through whatever device you're using. And that also means that any device that's connected to the internet is going to have its own IP address. And the IP address will look like something like this: 127.0.0.1 or 192.168. These X's actually represent numbers. So it would be 192.168.0.1 or something like that. So that's what IP addresses look like. Okay, so IP addresses live in the network layer. And basically, at this point, they're talking about the OSI model, which is Open Systems Interconnection. And basically, the data, and if you scroll down a bit here, this is the OSI model. There's 7 layers of the OSI model. Now, what exactly is the OSI model? Well, the OSI model is basically, you have to have a standard on how things are being done. Because if you don't have a standard, or basically, I would say something like rules on how things should be done, well, how can things work together if there isn't any rules on how things are done? So for example, this OSI model here, you actually go through these layers, and each one of these layers actually has specific tasks that need to be done during each of those layers. So, and if you look at it here, here's the application layer. An application is exactly what it sounds like. So an application would be like the browser that you're watching this on, or maybe you have Zoom installed on your computer. Microsoft Word, those are applications. So that's the very top layer here, and this is where the users are at. And the user, or you, is going to have data that's going to go through the OSI model, starting with the application layer, all the way down to presentation, session, transport, network layer, data link layer, physical layer. And the physical layer is where there's an actual physical link, which would be the wireless connection, radio signals, or possibly a cable if you have a cable connected to your computer. And then we go back up the OSI model to go to the destination where the data is received, to another user or another place, like a server if you're accessing information from your bank account. So basically, this is the standard of how information goes through the network. At the application layer, it does something. At the presentation layer, it has to do something. Session, transport, and on and on. So, so this is the standard of how things are set up to go through the network. In the paragraph above, it said that the IP address is taken care of in the network layer, which is this one right here. Okay, here are a couple more illustrations, a bit more simplistic. So if you look at here, host A and host B. So if you look at this topology here, this host A, you can say that this is your device, your laptop, your computer, whatever you're using right now. This router would be your router that you have sitting in your living room or your office, wherever. then if you think about it, well, I am basically, or I'm the destination of, when you text something in the chat, well, I'm the destination here. So I'm this host B, and this would be my router. And this is a very simple illustration, because basically your router doesn't really contact my router directly. It actually goes through a lot of different routers. It goes to your internet service provider, where you pay for the internet, and then it'll go through a whole bunch of different routers, different hops, all through the internet, to finally meet up with my internet service provider, and then down to my router, and then down to my PC or my laptop. So that's basically a very simple topology of, how we are connected, you and me. Okay, data flow here. This is a good illustration, because notice how this layer here, internet, this is where the IP address stays, or is evaluated. It said network layer when it came to the OSI model, but in the TCP/IP model, it's the internet layer. And notice how, remember I said that, data goes from one user, all the way down the OSI model, and all the way back when it's received. But in between this transmission and receiving, just like I mentioned earlier, that these routers here, they're not exactly connected to one another. There's still a lot of, internet servers that are connected to eventually get to my router. So the data will actually go from your application down the OSI model. And then once you start going out into the internet, it really only goes into this internet or network layer to find out what the next hop is. So it goes down all the way to the OSI model. Then let's say it gets to your ISP here. Then your ISP says, okay, this IP address goes somewhere through this router. So then it'll send it out, then it'll go here. That router evaluates the IP address, and it says, okay, well, now it needs to go somewhere else. So then it sends it out, and then eventually it'll go to my application. So yes, this is a very simple topology here, but this happens over and over again, this middle part, just so that your data or whatever you're sending out will get to the destination. And that may be a lot more than you really need to know. But anyway, so let's see. Okay, so we have this paragraph here is about private addresses. So, there's IP version 4, which is IP addresses. And it's version 4, which means that it has four numbers separated by decimals. There's 2 numbers with decimals, another number, decimal, and then another number. That's what IP addresses look like, and that's what an IP version 4 address looks like. If you scroll down a bit here, we have an IP version 6 address, and this is what it would look like here. It's much longer because we need to, basically we ran out of addresses on this date here. So then we had to find another way to get more addresses, because so many things are being assigned in their IP addresses. So, so this is what an IP version 6 address looks like. See, so it's not separated by dots. I mean, it could be. There's many different ways you can represent an IP version 6 address. Typically, it'll have colons, but also notice that there's numbers and there's letters. So then the question would be, let me actually close my email. Okay. So there would actually be letters and numbers. Now the question is, well, how many letters and how many numbers? Well, it is, the address would be hexadecimal. And well, what does hexadecimal mean? Hexadecimal means that there are 16 characters that you can use. Here's a little bit more about hexadecimal. And think about, I know that this might be something new for you. So, so let me just say that decimal numbers are the numbers that we typically use. You know, we count 1, 2, 3, 4, 5, 10, 100. That's just the way we normally count. So that's a decimal. But also know that you probably know that computers, they communicate through binary, which is just ones and zeros. So that's binary. So we have binary, ones and zeros. We have decimal, that is really 0 through 9. And then, of course, you can put more, like, 0 through 9, and then any combination of that. So 10 is really a combination of 1 and 0. 23 is a combination of 2 and 3. So 0 through 9 is really the base numbers of what you have when you're doing decimal. When it comes to hexadecimal, the base numbers that you'll have, or the base characters, would be 0 through 9 and A through F. So you can have any combination of those to have a hexadecimal number. So here's 2001, 0DB8, 85A3, and on. So that's the hexadecimal number. And an IP version 6 number, IP address will have 8 blocks of 4 hexadecimal digits. And you probably have already done this. You may have already done this, but there is a way to make this into binary. It's just ones and zeros. And just like these addresses here, 192, 168, 125, that there's a way to make that into binary. Because remember, everything that we look at, everything that we do with the computer doesn't really understand, these words. They really understand the ones and zeros behind all of these words here. Okay, so so let's look at these addresses a little bit here. So remember too, I talked about how we ran out of addresses to assign to different devices. So we came out with IP version 6. Well, one of the things that they did before IP version 6 is they created private addresses. Now, these private addresses actually extend the amount of addresses that you can have. And if you look here, there are ranges that you can have to assign to any device within your own private network. So we all have our own router in our own homes or businesses. So each one of these can be assigned within our network. So on our side of the router, you can have any one of these addresses here. And actually, let me scroll up a bit to kind of show you. Remember this network topology here? This is you, host A. Here's a router. Well, basically, this router, basically anything that the router is separating is a network. So This router here has a connection to your host, but it also has a connection to your cell phone or your mom's cell phone or your brother's or sister's cell phone. All of those devices that are connected to this router is a network. And all of those devices here have to be assigned an IP address. But, there's not enough addresses out there to give, or at least when we had IP version 4, there wasn't enough IP addresses out there to give each one of your device an address. So all of this network area here is assigned a private address instead. And it also means that even on my side, I'm host B, I can have lots of addresses too, now that there's private addresses. And what that means is that as long as it's within this area here, you have the ability to have all of the addresses within 192.168.0.0 and 192.168.0.255, because that would be, actually 255.255, because these addresses, the max would be 255. So I'm actually going to share the whiteboard for a minute. Okay, so do you see the white? Actually, you know what? I'm just going to share the entire screen. Okay, so this is my screen. And I am going to do a Word document. Okay, so basically, and see these X's here, that means from minimum to maximum. And no blocks could exceed 255, but it starts at 0. So what it means then is that 192.168.0.0 through 192.168.255.255, because 255 is the highest number and 0 is the lowest number that you can have in this section of the IP address. So that's what that means, 192.168.0 through 255 on each one of these. So 0 on this third section, and then 255, and then 0, and then 255. So generally the same here. This is another range of private addresses. And remember, private addresses are the addresses that you could use within your own network. And I'll expand on that in just a second, but let me go ahead and continue 172.16.0.0 through 172.31.255.255. Notice that this one has 16. This is the second section, and this is the second section as well. So 16 through 31. Okay, and then this, and then we have basically anything that starts with a 10. So you can do 10.0.0.0 through 10.255.255.255. So those are the private addresses. So, and remember also that these are the addresses that you can have within your own network. So we were looking at this as you, or the device you're using right now, and here's the router for your home or your office. All this area here, you have all of these addresses to use. And of course, that really doesn't make much sense if you're at home, because you don't need like a million addresses at home. But it does make sense when you're in a business, you need lots of, well, I guess it just depends on how big your business is, but you will need a lot of addresses to give to all of your employees and all of their devices. So that's where all of these address gets can be used. Now, let me just clarify just a little bit more on this. If we're using this range, this last range of IP addresses, know that when I say through, it actually means just, continuing on with the address. So 10.0.0.0 is an address, and then we have 10.0.0.1, and then 10.0.0.2, and so on. And then there's 3, 4, 5, and then you just keep on going until you max all of these here. So the address right above this one would be 10.255.255.254. That would be the address right before this one. Okay. So anyways, anything in between these ranges could be an IP address that you could assign to any of your devices at home. And of course, you could assign it if you wanted to, but typically the router would do it automatically. And when you create your own networks, it depends on whether you want to assign one automatically or manually. If you think about, you have a lot of, at your school, there's a lot of computers. Do you really want to go through all of those computers and do it manually? That would be a lot of work. So that's why it's good to have an automatic method. Okay, so now we have packets. Packets are really good, and it allows us to get through the internet quicker, really, or data to get through the internet quicker. Because remember, I mentioned that there are different let me go back up here. Remember, the data flow, it goes from your application to a destination application, but in between, it goes through a lot of different routers just to get to the app, to the destination here. So while it's going through these different locations, the data is being broken up into different pieces, and those pieces are called packets. And basically, if you think about the internet, it's just a bunch of connections going from one place to the other. And actually, let me just make another illustration using Paint. Okay, so if you think of the internet, you have, a bunch of different computers, you have different companies, you have your friends, your family, everybody has a computer, and the internet is just a bunch of, connections from one to the other. And let's just say that not only are all of these circles, different people, but they are also different routers, because everybody has to have a connection, from their router to get to somewhere else. Okay, so these are all the this is an example of the connections on the internet. So when, let's say this is you. Okay, I didn't want to make that red. Okay, let's go ahead and put that line back. Okay, so let's say this is you here, and you want to send a message maybe to somebody over here. Okay, now the ideal situation would be that, well, you could just send data from your router to their router, And that's fine, and that's possible. But so many times, or basically to get your data there quicker, you can break it up into packets and not only send something straight that way, but also have another another piece of your data, which is called packets, going that way at the same time and going that way at the same time. So eventually it's quicker to get to one destination by breaking it up into pieces. And then at the destination, you will then basically the computer will put it all together in the message. So let's say, so let me go ahead and stop here. And I want to make sure that you are okay with everything. Hold on just a second. All right, so let's see. Okay, I already talked about IP version 6. And here again, it talks about packets, how they're broken down into multiple pieces. And then at the destination, they are being put back together. And of course, since they're being broken up into little pieces and they have different pathways to the destination, at the end, they need to be put in order. And okay, well, then it starts talking about how the packets also have information on it so that it can be put back in order. And the information is actually listed here. So here's the data on the bottom here. And that data is your email. But since it's broken up into different pieces, all this information up on top in the blue, okay, in blue, gives the computer the information that it needs to get your email back in order the way you sent it. So here's the source address, the destination address. These are the IP addresses, version, time to live, protocol, lots of different things. You don't really need to know the specifics on here for this class, but just know that this is how it's broken down into packets. Your emails or whatever you send over the internet is broken down into packets, but then it's put together with this information in this header here. Okay, so URLs. Okay, so URLs, yeah, okay. So basically what they're talking about here is that, when we go to a web address, we go to, something like google.com or chasebank.com, something like that. But that computers really only understand binary, which is numbers. So even though you go to facebook.com, it's really going to go to something like 173.252.100.16. So yeah, that's the thing with the URLs. And there's a way, or there's a protocol that will basically translate facebook.com into the number where the computer can understand. And they're called name servers. Okay, when you look at a URL, www.facebook.com, know that there's 3 parts of that that address. There's the protocol, which is the HTTP, which is the browser protocol. And then we have your name and then the resource ID. So having all those 3 together will give you the actual URL. So here's HTTP for accessing websites, and they also give you an example for FTP, and that one is for using for moving files. But we really don't look at that very much. But that is another protocol that they use, that we use for the internet. And remember, protocols are the rules, just like I was just talking about the OSI model. It's a standard on how data should follow through so that it can be interpreted from the source to the destination. So that is a standard, and it's also very similar to a protocol, which is the rules that that we need to follow to get things done. So this is the file transfer protocol to move files, and then this is the hypertext transfer protocol to access websites. So again, I just wanted to point out that protocols are the rules on how things are done. Okay, so let's see. Okay, this section here talks about ports, and let me go back into the OSI model so I can kind of explain there. And well, let me just talk about this a little bit. Okay, so the ports are basically numbers assigned to different capabilities of your computer. So for example, port 80 is, the web traffic or the HTTP. Port 2021 is used for FTP. Now, if you go back into this, remember the IP version 4 packet, here is the protocol here. That is where the number lays, or where it's stored in the packet, to determine if it's a web packet, or if it's an FTP packet, or if it's whatever kind of packet. This one actually tells it what kind of packet it is. And the reason for putting these ports there is so that way it will know where to direct your data. Because if you think about it, what exactly are you doing right now on your computer? We're chatting, we're looking at web pages, we are doing voice, we're doing video. All those different things have different ports, and basically, or like your email too. So when you send data through with a packet, it needs to know where to send the data back to. So you don't want part of your email going into your chat, or part of your email going into a document. We want to label each one of those packets to tell it where it should go at the destination. And the transport layer is the layer where it actually keeps that information. So remember, we talked about the network layer, which is the layer where the IP address stays. Well, the port layer, once it gets to the destination, or once it's going to the destination, it knows that it's at the IP address. So then it goes down to the transport layer, and this is where it says, okay, now what program are we using again? Oh, okay, it's a chat. And then it goes down to the next layers and does the specific tasks of each layer. So that's why we have ports, to determine what type of data the data is, or where it should go when it gets to the destination. So that's the whole port thing here. And actually it's already 8:30, so I am going to go ahead. Okay, the next section is hosting facilities. And basically, as you read one of the earlier chapters, it talked about cloud computing. And basically, there's so many things that we can have done in the cloud. But so the cloud could be one of your hosting facilities, but also know that you can have your own computer as a host. You can have your computer as a server that provides web pages. So that's one hosting facility, but it's a really good idea to have cloud computing, because there's so many benefits to cloud computing. You can, you don't have to maintain the server. You don't have to have your computer on all the time, of course. And then there's backup, or what if there's issues, a power outage. If there's a power outage on your own computer, that means that people just can't visit your website anymore. So if you had something like or at least a place that could do the backup for you, and like cloud computing or other hosting facilities, then that would be much better for your website and your business or whatever you're doing online. So, and of course, you have to pay if you have hosting facilities that have your webpage there. Okay, and the last thing in this chapter is domain registrars. And basically, just like I said, that you can have your own, well, I guess just anywhere that you have a hosting, or where you're hosting your website, you can have your own URL. So you can have, yourname.com or whatever you choose to call it. So you would go to some place called like GoDaddy to figure out if what you want is available, and actually purchase that name and have your own site with your own name. Okay, so that is it for the chapter 4. Chapter 5, I will be starting on next time. So